You see, we are going to do ISIS. ISIS works in layer 2. That's very important. OSP works in layer 3. ISIS uses a unique identity called net ID or NSAP address. There is another word called NSAP, network entity title or NSAP. The reason is this is a protocol which is designed to support CLNS, connectionless network service, which is a very old protocol before IP. Later came IP. So now what we are having is a modified version of ISIS. The main difference between ISIS and OSPF is OSPF needs area 0 to be a backbone. Here you see any area can be a transit area. I would like to call it as transit area. Any area can be a transit area. What is important is L2. Layer 2, sorry, level 2 is what important. What is level 2 and level 1? Level 1 is an adjacency which is formed between the router which is in same area. For example, L1 and R1 and R2 will have L1 adjacency because both are in area 10. R2 and R3 will have L2 adjacency. You see this also L2 adjacency. It is must to have an L2 adjacency. Why? Because the interface which this router 2 is in is not the same area which the router 3 is. This is going to say I'm from area 10. This is going to say I'm from area 20. They will not form neighbor if it is OSPF. They won't form neighbor if it is OSPF. And they won't form neighbor if it is L1. If it is level 1, they won't form neighbor between the routers which are in different area. In order to form neighbor with these two routers which are in different area, you need L2. L2 adjacency is must. Now without L2, routers cannot learn other area routes. Now let us say I have only L1 here. So router 4 will not learn other area routes. If router 4 don't learn the routes coming from area 30, it won't learn, then it cannot give to R3 and R3 cannot give to area 10. That is the reason why in the transit area, we will have L2, level 2 on all areas. Every router is L2. Every router is L2. Only then this area route received here will be given to this router, and this router will give to this route, and this router will give to this route. See, you may have L1 here only, L1 only. No problem. Here also L1 only, no problem. But between the borders, you don't have an ABR. You don't have ABR like OSPF. So you must have what? L2. L2 alone can learn routes from other area. L1 cannot. So usually in the border, we will have L1/L2 router. L1/L2 router. Now within this transit area, it is your wish. You can have L1 and L2, or you can have all L2. No problem. No problem. Yeah. So what is important is L2 is important on these routers because it is in the transit. So it is not the area that is acting as the backbone. It is not area that is acting as a backbone. It is only this L2, continuous L2. Any area which has got the continuous L2 can become a backbone. Transit area can become a transit area, can become a backbone area. Next is there is no backup designated router in ISIS. You have only this. See, we used to call DR in OSPF and BDR in OSPF. You don't have a concept of BDR in ISIS. We have DR, we have BDR in OSPF. Equivalent to DR, equal to DR, you have designated intermediate system. That R is replaced with the word is. Intermediate system. And there is no BDs. There is no backup designator intermediate system. There is no BDs. Okay, we have this only. Next. In this ISIS, cost is not calculated based on bandwidth, whereas in OSPF, if you don't give cost, it is going to be auto cost in OSPF using bandwidth. In ISIS, each link cost is 10. Whether you have an Ethernet or gig Ethernet or fast Ethernet or any speed, doesn't matter. Cost is same. Each link is 10. For example, if R1 needs to go to R7, it is going to be 10, 20, 30, 40, 50, 60. 60 only always. Whatever the bandwidth you may have, it is going to be 60 only. So there is no auto calculation based on bandwidth. But you can manually go and configure bandwidth. Sorry, not bandwidth. You can go manually configure cost. If you have multiple paths and you prefer one path over the other, then you can go and give small cost. Cost can be manually configured. For the interface cost, the number of bits that are given is only 6 bits. So 2 to the power of 6 is what? What is 2 to the power of 6? Sorry. So you cannot have cost more than 64 by default. But if you wish to give big number, what you can do is you can make the metric style as wide metric style. By default, the metric style is narrow and it is only 6-bit. You should give only number less than 64 per link. The default is 10. You cannot give 70. But if you change into wide metric, then you can give 70. And if you configure wide metric on one router, you must configure on every router. Fine. So up to here, I would like to do the lab.